In this video, we solve exercise 3.3. This is a bit different different questions. There are two questions in fact, but I am going to solve only part B. This question says that if we have a matrix, A, and there is a left state and there is a right state, it says that find a solution and then sketch the figure in the xt plane. So first we find a solution, but before we find a solution, one short question that we can ask from from this part B. How many PDs are there? There are three PDs. Although it is not given, those PDs are not given over here, but we can see there are three rows, and we also have three left states and three right states. So it means that there are three PDEs, and those PDEs are not given. As usual, what we do, we try to find the eigenvalues, and we find the eigenvalues from this equation. We solve it, and there are three eigenvalues given over here, and these eigenvalues are the speed of characteristics. Then again we find the eigenvectors, so we can find it eigenvectors, since we already have done work on this finding eigenvectors, so you can find eigenvectors very easily. Now, from the theory, you know that we have uh, q right minus q left is equal to some alpha which is multiplied with r, alpha p rp. It depends how many waves we have. In this case, we have three waves. So first we need to find the qr minus q left. Qr minus q left is equal to alpha p rp. So first we find qr minus q left, and this value is 2 2 2. So we put this value over here, 2 2 and 2, something like that. Then we write this as a linear combination like we did over here. Now our aim is to find the alpha. What is alpha 1, alpha 2 and alpha 3? What are their values? This cannot be equal. So when we multiply when we solve this equation, we get alpha 2 and alpha 3. And similarly, when we put this value alpha 3 over here, we get alpha 1. So this is the unknown that we need to find when we have a discontinuity. Now remember that we have three eigenvalues. Lambda 1 is 1, lambda 2 is 2, lambda 3 is 3. You can use different notation. For example, lambda 1 is 1, lambda 2 is 2, and lambda 3 is 3. It is fine. This is just a notation. Now, if you want to draw that, then you can draw it like this. For example, we have x is equal to lambda 1t, x is equal to lambda 2t, x is equal to lambda 3t. So x will be equal to t. The second x will be 2t, and x is 3t. Okay. Now we draw these characteristics. The first characteristic will be x is equal to t. The second characteristic from here, that will be t is equal to x by 2. Since your y-axis is t and your x-axis is x. So this will be x is equal to 2t. And then we have a third characteristics, x is equal to 3t. And remember that we have q left and q right over here, and there are two extra region created due to these characteristics. One is this one and another one is q right steric. Okay, so this is similar to what you know from the theory. These characteristics actually divide your region into some extra regions coming from the characteristics. Okay, I hope you got this point. Now, these extra regions, you need solution for that as well. So we saw that in the theory. Probably you, if you just take a look on the book, then you can see that qxt is equal to q left, and there is some summation. So this becomes qxt is equal to q left plus, when x is greater than lambda 1t, here you can see that there is a region contribution coming from. So we have x greater than, you just solve it. For example, x over t is greater than lambda I. When we have lambda 1, x over t greater than lambda 1, then x is greater than lambda 1t. If it is lambda 2, then x is greater than lambda 2. When it is x lambda 3, then we have x is greater than lambda 3t. So x is greater than lambda 1t. Then we have, it depends how many contributions are coming from which wave. Alpha 1, for example, R1, or maybe alpha I, Ri simply. So that's how we solve the problem. Now, as we saw that we have three waves. One is x less than, this is x is equal to t, this is x is equal to 2t, and this is x is equal to 3t. This is for x is less than t. Here, when we have any point, this point is trapped in x is greater than t and less than 2t. And here, this point is trapped between x is greater than 2t and less than 3t. And then we have q right, the right region. Here we have q left. This is q left steric, and this is q right steric. Okay. So now we aim to find the solution at x is less than t. So for x is less than t, there is no contribution coming from alpha and Ri. So only we have q left. So q left was given in the question. The next one is x is greater than 2t and less than 2t, greater than t and less than 2t. In that case, the contribution is coming from lambda 1 is equal to 1. That's how you understand. For example, we know that we have qx0 is equal to q left if x is less than 0, and q right if x is greater than 0. When we have a solution qxt, that will be equal to q left, q right if x is less than lambda pt, x is greater than lambda pt. P can be 1, 2, and 3. When P is equal to 1, x is less than lambda 1t, and lambda 1t stands for the wave speed of first characteristic. So we have q left, and for x is greater than, we have only q right. Okay, so in that case the contribution is coming from only from lambda 1 is equal to 1, and there is for alpha 1 what we have, eigenvector that we found earlier was 100, and then we have alpha 1, we already found alpha 1 is equal to -2. So we solve it, we get first solution in this state. Similarly, when x is greater than 2t and less than 3t, the contribution is coming from two waves. One is on the left side, x is equal to t, and another one is from x is equal to 2t. So there are two extra conditions, like over here. We are solving this problem, this equation. When we solve it, we get two solution. We get another solution. Then for x is greater than 3t, we have the solution is coming from three waves. Since we have these three waves and we are here, and the wave reached at this point, and the contribution coming from all three waves over here. That's why we have all the three, alpha 1, alpha 2, and alpha 3. And we also have R as well, R1, R2, and R3. So Q left plus three waves, we get this equation. So the QXT will be equal to this term. This was the figure which was referred by in the question. Here you can see that initially we have only left and right state, Q left and Q right state. But when the solution evolve, we have three characteristics. These are the three characteristics, and this is left state, this is right state, and in between there are two intermediate states. This point is covered by these three characteristics, bounded by three characteristics. So this is figure 3.3. So if you see the theory, then you can understand that when we have a jump, there is a jump. This is discontinuity. There is a jump in from here to here. Then there is a jump from here to here. That's why we have Q R minus Q left is equal to alpha. It should be some function of Rp, and there should be some unknown over here. This is similar to what we did before when we have Rw or something like that. So this was exercise 3.3. Thank you for watching.